In this video we will talk about testing and more precisely about unit testing. So, testing. Why to test, how to test, what to test and how much to test. Those are the questions we are trying to answer in this video. So, why to test? First we can say that we can do manual testing. So if I write the code, I can manually print out some values. This is really annoying. It takes a lot of time. So if I have a lot of code, I have to manually kind of verify that everything I print out is exactly what is needed. So this is really hard to automate. So I have to manually check the values, I have to execute the tests and so on. It takes a lot of time. So if I have a lot of functionality, I have a huge project, it takes time to verify that everything that is printed out is exactly the same as required. And depending on what are you testing, it can be quite hard. For example, if you test your local code, it's a bit easier. But if you want to test something in the server or somewhere else, then it already becomes more complicated. You have to get into the server, and then usually the result of this application is not really easily to kind of it's not visible what's actually going on in this server or in this application. So you have to do or take additional steps to kind of verify what's going on. And every time you change something, you have to again test everything what you already have done. So actually, and why we do want to test is that we want to find the situations where the code doesn't do what is required or where the problems occur. And it's better to find out those situations before you, I don't know, give the code to client or launch it into the live environment and so on. So we want to make sure that everything works as expected, and we want to find those problems beforehand. And for example, if you try to fix something, it's really nice to know that if you fix something here, something else won't break somewhere else. So that's also something we want to do often. So if you write some small piece of code, it would be nice to not break everything else. And yeah, with testing, we actually want to verify that the code does what it is required to do. And of course, it's not always, we cannot verify or we cannot say that if we have tests, we can verify that it's doing 100% what's expected, but still it gives us some ways to verify it or at least get it better than without tests. So how to test? We have different testing methodologies and then different ways and different things to test actually. And unit testing is the main thing, and what we are covering here is that we test a function or a class or a small piece of code, and we expect this function to do something certain, and then we can see that if I call out this function, I get this result. Then we also have integration testing. So there we can see how different components interact with each other. This is often done in bigger projects where you have different components, for example, in different servers, different devices and so on. Then you can, for example, use integration testing. Then we can use system testing, which tests the whole system. So basically, if you have several components, then you try to put them all together and see that everything works as expected. Then we also have user interface testing, user experience testing, load testing, and so on. So there are actually different things to test. Of course, there are always not so, it's not so fixed what is meant by one or another, but basically, yeah, there are different things to test. And the idea or why we test is that we want to make sure that what we have done, this works. So, and let's talk about unit testing. So the unit testing is the idea behind it is that we want to use or test small functions, and by doing that we can say that maybe or this whole system probably works. But if we already see that some small functions do not do what's expected, we can say that the whole system probably breaks also. So, and anyway, if we are doing some projects or coding, it's always wise to divide our code into smaller pieces. It's better to write your code so, and it's better to maintenance later on, but it's also better to test your code if you have smaller parts what you want to test. So let's say we have a function here, or we have a application or system here, and basically as we have said that usually we say that we have some input and we have some output. So it can be our whole application, but it can be also a smaller function. Basically there is something in and there is something to be done, and then there is an output. And let's say during this black box here or this application or function, we actually do have some smaller steps. So we do something and then we do something else and then we do something else. So basically we can say that those are the lines of code. So even if there's 3 lines of code, we can say that this is the first line, this is the second line, and the third line. Basically this should cover this whole box here. And now if I, for example, execute or try to test it and pass in something and see that there is an error, something happens inside this function or this application, it's really hard to actually know what was wrong. Of course, I can verify that the program doesn't do what's expected. I already have covered at least part the idea behind testing. I know that I cannot put it into live or give it to a client and so on. I know that my code doesn't work. But now if I see that I have a problem, it's really hard to actually do something about it. I probably have to debug, see what was the input, what was the output, and see where exactly in my code this problem happened. So instead, we try to divide our function or program into smaller parts. And now what happens is that if I see that the problem occurs here, let's say here, then it's already more concrete, and as a maintainer or developer, I can take this function and see what's going on in this function. So instead I know that this one was okay, but this one has a problem. And now I already know that I have to deal with this function and that I can fix it or do whatever is needed. So this is why we actually want to divide our code into smaller parts so that I can easily understand where the problem is, and it's also easier to fix those. Also, if you have those smaller problems or smaller kind of functions, you can name them. And you can, for example, if this application here is, let's say it's a game, or game is not, let's say it's application. And if I execute my tests, I can just say that application is wrong. But now I can actually give better names to my testing functions, and I can also inside, or let's say this is a certain function, I can test this function with different inputs. And if I name my function so that I also specify what was the input, what was expected output, or what happened, then it's even easier to understand what was the problem. So often what we do, even if we have smaller function, we even then divide this testing this one function into smaller testing parts. So we, for example, test with certain values, with positive numbers, then negative numbers, then with 0, for example, and so on. So we can have different problems. but we will get to that later. So basically what unit testing does is that we give something in and we say that we expect this kind of value. So if I call this, for example, this value with number 7, I want to see that the result is 8, for example, if it asks you add one number. So what to test? So as I said, one functionality can be tested with different inputs. And one way would be to, for example, first test the standard situation. So for example, if I have a some, I don't know, division, then I can just try to divide certain normal numbers. So I can just see what happens if there is nothing special, or we just, basically we can see that the code does what it's meant to do. Then we probably have to test the edge cases. The edge case can here be that I cannot divide by 0 probably, so the code has to do something special for that situation. Also, it's also wise if I have numbers, try to test with positive numbers, negative numbers. Often the 0 is a special case, especially if we want to divide with it, and so on. Or if I have, for example, string as an input for my function, then it's probably wise to test with an empty string, maybe with a long string, maybe with some specific symbols inside my string, and so on. Then often we can try to test absurd situations, for example, if I pass in the a value, but this is often not the real case. For example, if I say that I have two numbers and I want to divide them, then we probably don't expect that someone passes in a string there. But still, this is something you can think of when you're writing tests. Then we can, for example, test the effectiveness of our algorithm. So for example, is it fast enough? So the performance time-wise. So for example, if I execute it with a large or huge input, then it takes, I don't know, maybe 10 seconds, but if it takes 1 minute, then it's too long. So I have to probably do something. Whether it's using memory efficiently. So for example, if it takes too much memory, or I don't know, memory it basically takes all the memory what it has and cannot do anything more, then it's also not a good solution probably. And then we probably want to do some error and exception handling. So for example, this absurd case or this edge case, if I pass in something which is not a normal value, whether this function performs as expected. So it doesn't give me an error, it doesn't give me an exception, and so on. So it depends, of course. If the function has to give me an error, then we probably have to test it also. But usually we don't want to see exceptions. We want those exceptions to be handled inside the function, or of course it also depends on the situation or the requirements. So how much to test? We can say the more you test, the better. So the more tests you have, probably you have covered most of the or all the edge cases and the different situations. And usually we can there is a special value or a special kind of ratio, which is called code coverage. And basically it says how many lines from the code are covered by tests, or how many percentage of the code lines. It can be also measured in, for example, how many methods or how many functions or how many classes, how many files, how many folders, so on. So basically, we usually mean that if I have a code of, I don't know, 100 lines of code, and if 90 lines are covered, I can say that my code coverage is 90%. So if I execute my tests, certain lines are visited. So if I have, for example, a code where I have if sentence here or if statement. So if something, then do this, and else do this. Now if I test my code, let's say the input is let's say x. If x is 1, do something like that. Now if I call out this function and I pass in this x with the value 1, then those lines are executed. And if that's all, then all those lines are not covered because we didn't test our code with different values. So then I probably have to pass in x is 0 or x is 11, and then those lines are also covered. So basically every line which is kind of visited, this is said that this is covered. And usually our normal programs have different branches. So this is like the if-else branch here, or loops or whatever. Then you have to be certain that you test basically every branch. That's the idea behind the code coverage here. And yeah, we can try to cover every possible branch. So basically if I have, here I have 2 branches, so basically I have to have at least 2 tests. If I have 4 branches, I have to have at least 4 tests. I can have nested branches, so inside my if sentence or if branch, I can have a separate or different if branch, and then I probably have to try to cover all those branches. Now the thing is that, for example, this concrete example where I said that x is 1, I have to do something special. And now I have probably misunderstood or haven't thought about special case if x is 0. What happens then? And if I haven't implemented a special branch or a special solution for that, everything is covered here. So if x is 0, but also if x is 7, for example. So everything is covered here. So the thing is that if I haven't written a special case for x is 0, I cannot test it really. Of course, I can pass in this 0, but because the result is same as with the x is 7, then I really cannot test this one specifically. So yeah, this depending on the situation, the 70 or 80% of code coverage is a good goal. And also, as I mentioned before, that if there is something not implemented, I cannot really test it. That's the problem, or one of the problems with testing, or why you cannot take testing as something silver bullet which covers all the problems you have in your code. And let's say you write your code and you write tests for that, and you get code coverage 100%, which is good. You have tested basically every different branch in your code. And now if you have 100% of code coverage and everything works, the idea behind testing is that all the tests should pass. If something fails, then it's already bad. And you are pretty pleased with yourself. So you have written tests which pass, and you have got 100% code coverage. The thing is that even then, what you test what is implemented. And if there is some cases which you haven't implemented, and you don't test those specifically, but you just write your tests based on your code, then it can really happen that you just write the tests based on your code, and it doesn't, or this is not the way to go actually. To write tests, it's recommended to use requirements to actually write your tests. So you take, for example, you have a exercise or a problem, and you usually have some requirements. So for example, if I pass in 0, then do that. If I pass in some positive number, do that, and so on. Or for example, if you have a list of numbers, if you have an empty list, then you do something specific, and so on. So basically, often what is done is that the requirements are taken. Based on the requirements, the tests are written, and now I can try to kind of write the solution so that I pass my tests. So, and it's often called test-driven development. So I start with testing, and then I actually write the code. And some also say that these tests or tests can be as basically as the requirement for a problem. So basically, instead of writing a piece of text, I can write a test or tests, and based on those tests, you should be able to implement what is required. And let's have an example. So I will try to have a testing written for specific problem. This is pretty standard example. So we have this quadratic equation, and I want to see the solutions for that. I pass in the different multipliers for different kind of like parts, and I want to see what are the solutions. So you often, for quadratic equation, we have two solutions, and this is the simple solution or the code for that. So I have taken this code and I've put it into my PyCharm. Here I actually have to import math because I use square root from math library or module. And I have this function. So I have, it takes two or three elements or three arguments. First is the multiplier of this x square. Then is the multiplier of x, and then there's this just like the constant way or multiplier for this whatever term it is. And this is just basic solution. I have taken the formula for this quadratic equation solution, and it has two results, x1 and x2. So basically I just take some square root, and for one solution I have to add here, and for one I have to subtract something, and basically this is the formula. Here I have nothing special. It should be the standard solution for quadratic equation. And now let's try to write tests for this code. So first, although Python actually has a unit test library built in, we are using PyTest. PyTest is a separate basically library which we use, which is a bit simpler and it's easier to start with. And how to get this PyTest into PyCharm. So first I take this project interpreter and I try to find this install button. So I take File and Settings and Python interpreter here. So it's under Project in the Settings menu. There is this Python interpreter, and now I see actually all my packages which are installed in my Python environment. And now I should have this plus sign here. So plus, which installs new packages. And it opens a new dialog where I can write in PyTest. And this is the first one which doesn't have anything added to it. This is the one we want to install, and there's this button install package. So it takes some time. It installs this package and it says that yeah, everything is installed successfully. Okay. And now I actually see this PyTest here. Actually, in addition to this PyTest, different other packages were installed. As you can see, I already only had this pip and something else here. So okay, I'm happy with that. And now I take the separate file where I write my tests. And first what I want to do is to import PyTest. This might not be required depending on the what we are using, but let's just import this PyTest. One way, and why I also want to import this PyTest is that we can make sure that we have this PyTest. If I don't, I would see a red line under that PyTest here. Yeah, that's what I did. I searched for PyTest and I installed. Now, it can happen that by default, the PyCharm uses unit testing or unit test library to test your code. Then we have to specify that we want to use PyTest instead. So I take settings, tools, and Python integrated tools. Let's find it out. So file, settings, tools. It was under tools, Python integrated tools. And here it shows us the default test runner, this one here. And here I have different selections or different ways, selections, and here I should select PyTest. I'm not even sure. Okay, this auto detect also showed me this PyTest. If I don't have PyTest installed, then it's probably something else. And let's say okay. And now I can run this my test file. Here I have different name here. I have solver. In my examples I had equation, so it doesn't actually matter. This is the name of the file. And now if I want to run it, I can take run menu and run with 3 dots. Because otherwise, if I run this code, it runs it as a standard Python file. And then what happens is that it usually in my test file, I don't have any code outside of the functions, and then nothing happens. Let's write something. So basically, before we try to run it, I usually write test functions here. So I define a function and it starts with test. Then I use underscore. That's just test standard. So some standard situation. There is no parameters here, and inside my test I do something. Let's just write pass currently. Now if I would just run it, so let's take the right. Okay, in right click I already have this run PyTest. But if I would click, okay, anyway, the idea is that however you run your code, but let's say I take this run menu and execute this run with 3 dots, I should have a selection where it says PyTest in solver underscore test. So basically PyTest in your file name. And if I run it, currently I can see that something happened. And let's try to see what's happened here. So down here on the left side, it should be here. It probably can happen that you see the same result somewhere else on your screen. But here I have test results. And currently it shows me that there is one green checkbox or check mark. And I have this small arrow here, so I probably can expand this list. If I click it, okay, it doesn't actually show me anything. Okay, probably I don't have any real tests here. Let's write some tests and then maybe we can see something. Okay, the thing is that by default, it doesn't show me past tests. Let's say I have hundreds of tests, and I often don't care about those which are passed. I only care about those which are failed. And by default, here is an option to select whether it shows me passed tests or failed tests. The failed tests is kind of like selected. Now I just mark this passed tests also, because then it's easier to understand. And now I see that I have this solver tests file name and I have this test standard, which is one test function, and it passes. And currently I don't have any body or anything inside my function, so that's the reason why it's passed. So before we actually start writing our tests, let's talk about the assert statement. And assert statement is in the form, I write assert, and then there is a condition. And if the condition is false, so I do something which gives me a false, then assertion error is thrown. And if this assertion error is thrown, then basically this test fails, or this test function fails. If this condition is true, the code continues and nothing happens for that line. And usually inside one function we want to test one situation. And we also want to test or name our tests clearly, so we understand what is tested and how and so on. Then we can have an overview what has happened. So we will see later on, this is the report of those failed tests. If the test name is ABC or 1, 2, 3, then it's really hard to understand what is the problem. I have to open this test function and see what was tested there. But instead, if I say that we try negative numbers, and if I see that this fails, I know that I have to do something with negative numbers and so on. Okay, let's try to write something here. And as was said, that I have to write assert statement here. Assert, and here has to be a condition, and the condition is usually in a form that I call out a function and compare whether it gives me the certain output. And here I have to take this, let's import this, because it's in a different file, I have to import my solver. And now I can, okay, I can also do, if I import solver, I have to call out solver and take this solve quadratic equation, which is okay, but it's a bit long. So instead I can actually do something like that. From solver, import, we import only the specific function. So if I do that, I can remove this one. I can already have it a bit shorter. So I only use this function. I only import this function from this module. But I can also give a specific name for that, let's say solve. And now I can use this function as solve inside my file here. So it's just to make it shorter. Usually it's not maybe recommended to do that, because you can mix something. So if I have a function called solve quadratic equation and I rename it as a print, for example, or print out something, then you can understand that it's mixed up. So if I check my code quickly and I don't understand what this function is. And now I call out this solve. I've put some examples here, 1 minus 3 and 2. And now I say that this result has to be 1 and 2, sorry. So this is the standard form for assert statement. So I call out my value, it's called actual value, the actual value what the code returns, and I compare it with the expected value. So if I call out this function, I expect it to give me this result. Now if I execute my code, I can see that yes, everything works. There is no problem. It gives me what is required. So if I, for example, for some reason I've said that it should be 3 here and execute my code, now I see that there is a failed test. It also gives me the total that I have 1 failed test out of 1 test. And now I can see, of course, this name can be a bit better, but basically I can see that this test has failed. And this is failed because this equation here is false, or this condition is false. This does not equal to that. Currently it was just to give you an example how the failed test works. So I don't want to do that. But probably what is wise to, even though often it's said that we should test one thing inside one function, you can still test, you can still have several assert statements. So for example, if it's a standard test, then we can use some different other normal values here, which give me some result. But let's say we are pleased with that. So let's have a different test which tests the floating point result. So because currently I was checking for a result which is a integers, gives me integers, then I want to see whether also floating point numbers work. For example, maybe for some reason this function rounds up the numbers and then I have a wrong result. So then I assert solve. I also see what was here. 1 minus 4 and what was it? 3.75. So something like that. And now I should get 1.5 and 2.5. So let's execute my code, and yeah, I can see that two functions both pass. Okay, so now let's think about different corner cases or edge cases. And one would be what happens or what our program does if there is only one solution. So with this equation, it can happen that one solution, that there's only one solution for your formula. So we can say that if I use solve, was it so? Minus 4 and 4 here, and then let's say our code should return only one value. What was it? 1, 2, okay. 2. So instead of returning a tuple of 2 values, I want to have a tuple of 1 value. Now if I execute my code, so let's say it's in the requirements. I didn't write any requirements or I didn't show you any requirements, but let's say it's in the requirements. Now I can see that, okay, my code or my solution doesn't cover that. What I can also do, if I click on this failed function, I see some additional output. And what happens is that it shows that the expected value was 2, only one element of 2. But what actually was given was that I received 2 values. So now I have to fix my code. And for that, we open this solve function and let's see what has to be done. So if we have one value, it only happens if this component, which is under this square root, is 0, this discriminant or whatever you call it, if this is 0. And if the value of this is 0, then it doesn't matter whether I add or subtract, I still get the same result. So minus b minus 0 and minus b plus 0 is the same. That's the reason why we have two same results. So we probably can do something like that. If this is 0, then we can return. Basically, I can copy it here, but it has to be still a tuple with one value. Okay, inside function, when I return, I can also use something like that. I have to have comma here, because otherwise it would be just a value. But now it's a tuple with one element. And because I know that this one is 0 anyway, I can write 0 here or just remove it. So basically it's minus b divided by 2 times a. And if I execute my tests again now, I can see that, yeah, I have also solved this test. Let's see what else I had here. Then I had this question of, for example, if I have all ones here, there's no solution. And probably if I have 1, 1, and 1, I should get none. So this is also probably in my code, it's not implemented. But if I have all those positive numbers, there is no way what x can be so that the equation would equal to 0. So basically it's whatever it's x square plus x plus 1. So whatever I put as a value of x, I cannot get this 0 result there. And let's see how to, let's first execute this code. So if I execute it, I probably get that it fails. I can also see what happens here. And now the problem is not with this assert, but the problem is actually inside my function, and it gives me an error here. It gives me an error because I tried to take the square root out of a negative number. And that is the problem. So even though we say that this assertion has to be true, and if it's false, then I will get an error. But if you get whatever error in your function, test function, it's failed automatically. So if there is a function, I will try to divide by 0, or I try to take square root from a negative number and so on, I get an error, and because of that the test fails. If this error is expected, then I can write the specific code for that, but basically currently it's expected that if I have an error, then the test fails. So what to do now here? So the thing is that if this part or this component is negative, if disk is below 0, then let's return none, because I cannot solve it. Of course, then actually can be a solution in a complex word or with complex values, but let's say in current solution or in current implementation, we don't have to take this into account. And now, yes, we get this none here. And now let's try to also see what happens if there is this square component or the multiplier. And now x square multiplier. Now assert, and I put this solve, and this multiplier or this value of a is 0. So basically I get a formulas basically 0 times x square, but this is not written, so it's basically x plus 1 equals 0. And now the question is what to do here. Because if let's first try to solve it. So if I write it so, I can say that -1 is okay solution. And let's say that because it always returns a tuple, I just use the same logic here as I did here. There is one solution and it's -1. And let's try to execute it, and I also get an error. And now the error is that I divide by 0. And now again, we can try to solve this somehow. It actually depends on our requirements for this problem. From some point of view, we can say that this is already not a square root equation, or it's not quadratic equation. This is a simpler equation, and for that, depending on our requirements, do we have to deal with this case or we don't? So maybe we can say that it's not expected for this function you get this 0 here. But still, depending on your requirements, you probably have to fix this one also. So if we don't have this square component, we can simplify this equation a bit. So basically we can divide this one with this one and put the minus sign in front of it. So we can try to solve it as that. So if this component here, if 2 times a is 0, or actually if a is 0, then what we want to do, we want to solve equation in a form that bx plus c is 0, or if we try to simplify it a bit, is that bx is same as minus c, and to get the x value we have to say that, sorry, x is minus c divided by b, or let's maybe call it like that. And here I can write this as that, minus c divided by b. And again, if I say that this has to return a tuple, then I just add a comma here to have a tuple with one element. And now if I execute my tests, I can see that everything is passed. One thing I probably should do is that currently I only have one function, but usually I have more. So it's at least wise to have this function name here. So I have test solve, so I know if I just check the list of tests, I already understand what was tested and where the problem was. If I have just test and description what was tested, it's already something better than test 1, test 2, test 3, but it's also wise to say what was tested. So test solve, no solution, test solve, no x square multiplier. So now it's a bit better. If I just check my report, I can see that, okay, those tests deal with this solve function. And if I have additional function, I can use that to in my test names, and then it's already understandable what was tested there. So let's try to take it to conclude that. So first, what we did, we tried to test the regular situation, then we tried to test floating point solutions, then we tried to test one solution, then where there was no solution, and division by zero solution. So we tried to test different cases, and the thing is that actually we didn't have like specific requirements. I just came up with those different cases, but actually often you have to come up with your own cases. For example, in my function, I had to come up with those multipliers. I did it beforehand, so it would take some time to kind of come up with different cases where we get one solution, when we get no solution, and so on. So it takes also a bit of time. And as with the fifth example, if I have this division by zero, it depends what are the requirements. For example, it can happen that if the multiplier for x square is 0, then we probably also maybe want to have none as a result, because it's not actually a quadratic equation and so on. But in our case, I solved it so that I tried to solve whatever is possible. Of course, then there is also this case if I have no multiplier for this linear term and so on. So let's conclude the testing part. So testing helps us to verify whether the code does what is required. We have some requirements, we write tests on that, and if we run our tests, we should see that everything is passed. And testing helps us to avoid mistakes. And if I see that some test is not passed, then I can see what was wrong and where it was wrong. So that's why you have to divide your code into smaller pieces, that it's easier to test and it's easier to maintain later on. Usually, the developer itself writes tests for his or her code. So there are actually companies where there is a separate tester as a kind of job description, but usually developer is the one who writes the code and writes tests for the code he or she writes. So if you write a function, you already should cover this function with unit tests. So you write a function and you write 5 tests for that, for example. And one test function should test one situation. So for example, test positive numbers, test negative numbers, test 0, test large numbers, test empty list, test large list, test list with only negative numbers, and so on. But inside one function, you can have several assert statements. So for example, if I test negative numbers, it's often easier to try different negative numbers in one function instead of writing, I don't know, 5 different negative number tests. But of course, it also depends on your requirements or what's expected from the project. For some projects, it's better to write several tests. For some projects, it's maybe expected to write one function for one situation, but inside the situation, it's okay to use several assert statements. So try to think always about testing, and it's also easier, even if you don't write tests specifically, it's nice to understand if you write a solution for a problem. Try to test or at least manually test your code with different cases. So normal case, edge cases, absurd cases, large, small, whatever cases. And of course, it's really easy to write this assert statement already in your code. And Python actually allows to use assert in your regular code. And how it works is that when we have tests and inside the test we get a search and error, then this test fails. But if you write assert in your regular code, it works as basically as inside the tests. You get the search and error if this test condition is not true. And if you get an exception, your program basically stops running. So you kind of have quick tests for your code instead of printing those code results out and comparing with your code. So for example, if I use this equation myself and I don't want or don't really need those tests as a separate file, I can, for example, print out. Let's see what's the solution for 1q minus 3, for example. If I run my code here, I can see that it's minus 3 and minus 1. Of course, I can say that it's expected minus 3 and 1, but instead I can use assert here. So I can just assert solve 1q minus 3, and this equals to minus 3 and 1. And now if I run my code, nothing happens because it's correct. I can write here, if I reach here, I can say that works. So if I reach this code, it works. But if I, for example, expect something else, let's say it's minus 4, then what happens is that I get a search and error in this line. And I don't reach to this works line because this search and error already stops or just terminates my execution of this code. So sometimes you just want to have those quick tests in your code. But yeah, it's preferred to have separate test file where you actually test different cases. And we probably can have a task or a problem or exercise for that where you have to write different tests for your, or not maybe only your code, but also the code provided by us. So let's test our code.